Okay, Assalamualaikum warahmatullahi wabarakatuh. Let us introduce ourselves from a first group from numerical method subject. We are a group of 4 people. There is me, myself, Aditya, Yudha, Januar, Rizky. There is Dewi Hariyani, Tolib Dzhumaev, and Daffa, Althaf, Muammar. And in our group, we got Lagrange interpolation method. The simplest is to simplify Lagrange interpolation is to substitute numerical values into formula. It's a sub material from interpolations. It's called Lagrange interpolation. So without further ado, let's get into it. So what are we going to study in this course or this method is we want to know the basic concept of Lagrange method, and then we want to see the application examples. There will be 3 examples that will be shared by each of members of this group, and then we want to know what are the advantages and the disadvantages, and then how this method is implemented in programming. So, Lagrange institution. Polynomial interpolation is used to construct a polynomial function px that passes through all given data points. The resulting polynomials of Lagrange interpolation is unique for given sets of data points, given the data points of x0, y0, x1, y1, up until xn point yn. So basically, what are we trying to solve is that we want to find specific point from a lot of data points. Here is the formula of the Lagrange interpolation polynomial. It's a px equals to sigma or sum of the yi times lix. And the lix itself is actually a sum of that specific data points. For example, the lix is a polynomial basis for point n, and the n itself is the number of data points. So for example, there is a 5 points, so the n will be 5, like that. We want to see the example of this method. First is used to estimate values between experimental measurement points such as velocity, force, or energy. For example, predicting the position of an object based on a discrete position and time data. Second one is reconstructing signal data by estimating missing or corrupted signal values. For example, inserting missing values in audio or video data. And for the dataset interpolation in machine learning is used to fill in missing data before model training. For example, filling in missing sensor data in an IoT dataset. So as you can imagine, the usage of this method is mostly for filling or estimating missing or corrupted data. And the advantages of this method is the formula directly gives the interpolation polynomial without requiring additional calculations such as differentiation or integration. And it is very suitable for small data sets, and it can be used for datasets that do not have the same distance between data. And if the number of data points is small, the results are very accurate in that interval. But there are also the disadvantages in this method. First, as the number of data points n increases, the interpolation polynomial becomes more complex. For data sets with many points or large ranges, the interpolation polynomials can oscillate drastically, resulting in inaccurate predictions, especially near the end of the interval. If a new data point is introduced, the entire polynomial calculation must be repeated from the beginning, unlike the Newton's method, that's our more modular method. And if there is a small error in single data points, the interpolation results can change significantly because each point contributes to the polynomial. Now, for the first example, like I said in the beginning, there are 3 examples that will be introduced and explained by each member of this group. Starting with the example 1 will be explained by Mbak Dewi. So please, Mbak Dewi.
Okay, thank you, Mas Aditya. So I will be explaining the example 1 in number of HIV sufferers. So given data on the number of HIV patients from 2005 until 2015 as the following table. In the year 2005, HIV suffer is 859. In the year 2026, the HIV suffer is 7,195. In the 2007, HIV suffer is 6,038. In the 2008, HIV suffer is 10,362. In the year 2009, HIV suffer is 9,793 and so on. From the table, predict how many people with HIV in 2016. Next one, Sati. Since the large-range interpolation method requires a number of data points, we have to select some point close to the year 2016 for calculation. For example, we select the data from the year X0 is X was 2014 and the X2 is 2015 with the number of HIV patients. Y0 is 29,037 and Y1 is 29,037. I'm sorry, 22,169 and Y2 is 1,513,609. Next message. And then calculate value of L0, L1, and L2 for X for 2016. From the L0 is equal to 2016 minus 2014 divided by 2013 minus 2014 multiplied by 2016 minus 2015 multiplied divided by 2013 minus 2015 is equal to multiply 35 minus 1 multiplied by 1 divided by minus 2, so equal to 2 divided 2 and 1. So the L1 is 2008. So the L1 is 2016 minus 2013 divided by 2004 minus 2013 multiplied by 2009, 2006 2005 and multiplied by 2014 minus 2015 is equal to 351 and multiplied by 1 divided by minus 1 and so equal minus 3. In the L by 2 is equal 2006 minus 2013 divided by 2015 minus 2013 multiplied by 2016 minus 2014 and then divided by 2015 minus 2014 is equal to 3 divided by 2 and multiplied 2 divided by 1 so is equal to 3. So the next step is compare the formula. So the P 2016 is Y0 multiplied by L0 and then add to Y1 and multiplied by L1 and so add to Y2 and L2 and then substitute value P 2016 29,037 times 1 plus 22,869 times negative 3 plus 1,513,608 times. Again, 29,037 minus 68,607 plus 4,540,824 equal to 4,509,254. So the number of people living the HIV in 2016 is predicted to be 4,509,254. And the next explanation will be explained by Tolib.
Oke, silakan.
In the second example, I'm gonna talk about the daily bus passengers. So we get as a second example daily bus passengers, and in the example we collect the data on average daily numbers of passengers on a bus for a period of the month. Period of the one month at a little. The data were recorded for the specific date. In first day we get the bus get the 50 passengers. So if the fifth day it was been a 70 passengers. 10th day it was a 65, 15, 75, 20, 85, 25 it was been 80. At the last it was been day 30 it was been 60 passengers. So our question is, what's the estimated average number of passengers and the day of 18? So our question gonna be about finding a passenger in the day of 18. So we are gonna start our solve the question step by step. The first step gonna be so we get the take a note about the day. So the X is actually the day of the month which we get in the example, and Y is the average number of passengers. So it's a passengers numbers, right? And we want to find the day the day of 18, how many passengers was been estimated in that day. So x0 was a y0. We put it as a days, like first day it was been x0 and y0. It means like a 50 passengers, number of passengers. So we get x1, y1, 5, 70, x2, y2, 10, 65, x3, y3, 25, x4, y4 is 20, 85, x5, y5, 25, 80. As the last is x6 as well. And the y6 is 60 at day of 60 and 60 passenger. 30th of day and 60 passenger. Next. So so the second step gonna be counting polynomials, and there is actually Lagrange of the formula of the Lagrange method, and phi of x is equal to sum of number I is equal to 0. It means initial is equal to 0. So y initial is a ly of x. It means ly is like a polynomial basis. We can get it polynomial basis is equal to number over g equal to 0. G is equal to not in initial. So x minus xj over xy minus xg is gonna be. So for using that to find the passenger and that 8 days of 18, we are gonna get nearest point, means like nearest day into the day of 18. So we get day 15, 20 and 25. So in day 15 it was been 75 per passenger, 20 it was been 85 passenger, 25 it was been 80 passenger. Next. So according to the formula, we are gonna get first polynomial based point was been 15 and 75. So we are gonna substitute all the numbers into the formula. The first one is L1 of x minus gonna be minus 20 times x minus 25 over 15 minus 20 and 15 minus 25 is equal to x minus 20 times x minus 25 over minus, as a result it's gonna be minus 5 times minus 10 and x minus 2 and x minus 25 times x minus 25 over 50. So we are gonna put the same thing, and then next Lagrange polynomial basis point, we're gonna substitute the day and passenger in that second formula. So L2 of x is equal to x minus 15 times x minus 25 over 20 minus 25 is equal to x minus 15 and x minus 25 over 5 minus 5 times x minus 15 minus x minus over 25. So we are gonna get the if in order nominal, if we times 5 times minus 25, it's gonna be minus 25, but we get the minus in the forward of it. So in the next Lagrange point, basis point, we're gonna be the third day is 25 and 80. L3 of x is equal to x minus 15 times x minus 20 over 25 minus 15 times 25 minus 20 is equal to x minus 15 and x minus 20 over 10 times 5 is equal to, it's gonna be x minus 5 times x minus 20 over 50. So we get all the Lagrange polynomial basis points, and we are gonna substitute another formula which I had shown in the next slide. So we need polynomial base and 8 day of 18. So instead of x, the x was been the day, so we are gonna substitute x into the 8, and we are gonna put all the, instead of all the x, we are gonna put the 18. So the first one gonna be L of 18 is equal to 18 minus 20 times 18 minus 25 over 15, which is given in the previous slide, and is equal to, it's gonna be minus 2 times minus 7 over 50. Minus gonna be automatically plus. 2 times 7 is gonna be 14 over 50 is equal to 0.28. The next one, the next question is L2. The next point is L2 of 18 is equal to 18 minus 15 times 18 minus 25 over 25, and is equal to, it was been a minus, so minus 3 times minus 7 over 25, so it will be minus and minus 21 over 25. It's gonna be 0 minus with minus, again as I said, it's gonna be automatically plus, so it will be as a result 0.84. For the last point, it's gonna be 18. The L3 of 18 is equal to 18 minus 15 times 18 minus 20 over 50 is equal to 3 times minus 2 over 50. 3 times minus 2, it's gonna be 6 minus 6 over 50, it's gonna be minus 0.12. Next step. So it was been the last step, and in last step we are gonna put multiply all the points we get in polynomial basis, and we are gonna multiply all the passengers to find the passenger at the day of 18. So P of 18, it's like day of 18, which we can take it 75 passenger times 0.8, which was in polynomial basis previous slide. L1 means if we take like a P of 18 is equal to 75 times L1 plus 85 times L2 plus 3 times L3. So if we substitute the L1, L2, and L3, it's gonna be 0.25, 0.84, and minus 0.12. So now we are gonna get the point. P of 18 is equal to 75 passenger times 0.85 probability plus 85 times 0.84 plus 80 times minus 0.12 is equal to P18 is equal to 21 plus 74.4 minus 0.96. So if we calculate all to be P is 82 point. So the conclusion of example 2, it's gonna be estimated average number of passengers on the day of 18 by using Lagrange interpolation formula is approximately 82.8 passengers at the day of 18. Thank you. It was been we are gonna make it next slide, gonna be example 3. Example 3 gonna be explained Mr. Muammar. Silakan.
Okay, for the third example, we have a question. In the time in 5 o'clock, the temperature is 16 Celsius. In the 6 o'clock, the temperature is 18 Celsius. At the 8 o'clock, the temperature is 22 Celsius. At the 9 o'clock, the temperature is 24 Celsius. And at the 10 o'clock, the temperature is 25 Celsius. The question is, what is the temperature at 7 o'clock? Next. Okay, before we serve the 7 o'clock temperature, we have to using a formula polynomial interpolation Lagrange like in the screen. Here x0 is 5, x is times, so x0 is 5 o'clock, y0 is 16. That is the temperature x1 6, y1 is 18, x2 is 8, y2 is 22, x3 is 9, y3 is 24, x4 is 10, y4 is 25. Next, before we calculate the formula of interpolation, like in the screen. Next, in the first step, we have to calculate the polynomial L0x equal x min 6, x min 8, x minus 9, x minus 10 divided by 5 min x, 5 minus 6, 5 minus 8, 5 minus 9, 5 minus 10. We have to change the x to 7 because we have to search the temperature at 7 o'clock. So L07 equal is 7 minus 6, 7 minus 8, 7 minus 9, 7 minus 10 divided by 5 minus 6, 5 minus 8, 5 minus 9, 5 minus 10. The equal is minus 9 divided by 16. 60, the equal is minus 0.1. Next is L1x. L1x equal x minus 5, x minus 8, x minus 9, x minus 10 divided by 6 minus 5, 6 by minus 8, 6 minus 9, 6 minus 10. We change the x to 7. L1 7 equals 7 minus 5, 7 minus 8, 7 minus 9, 7 minus 9, 6 minus 10. The equal is 0.5. Next. Okay. Next is the we search the L2. This is the same like we search the L0 and L1. So L2x equal x minus 5, x minus 9, x minus 9, x minus 10 divided by 8 minus 5, x minus 8 minus 6, x minus 9, 8 minus 10. We have to change x to 7. L2 7 equal 7 minus 5, 7 minus 9, 7 minus 9, 7 minus 10 divided by 8 minus 5, 8 minus 6, x minus 9, 8 minus 10. The equal is 1. For the L3, we have to use the same formula. The answer is minus 0.5, and for L5 the result is next. Okay, for the last step, P7 equal, we use the formula interpolar Lagrange. So y0 L0 7 plus y1 L1 0 plus y2 L2 0 plus y3 L3 7 plus y4 L4 7. Next step, we have to change the y and L to the result before. So P7 equal 16 minus 0.1 plus 18 minus 0.5 plus 22 1 plus 24 minus 0.5 plus 25 0.1. P7 equal minus 1.6 minus 9 plus 22 minus 12 plus 22.5. So we get the result is P7. So at the 7 o'clock is 19.9 Celsius. Okay, next.
Okay, now after we done with the 3 example that has been explained by our friends, we want to check their work with the MATLAB computer, MATLAB files, so that we can know whether their explanation is true or not. Okay, so as you guys can see in this page, we already designed the code for this method, and before we explain the code one by one, we will try if it works or not. But before that, as I said, we want to cross-check it. So we have to display also the works, starting from the first example here. Okay, let's see. Okay, it says how many data points is it? From Mbak Dewi's perspective, we have 3 data points. There are 2013, 2014, 2015. The first data is 2013, 2014, and 2015. The Y1 is 2937. Second is 22,869, and the Y3 is 1,513,608. Please fill the data that want to be interpolated. As in the example 1, we want to find the number of HIV patients in 2016, so we type 2016. Okay, so as we can see here, the answers is 4,501,254 patients. Is it the same as Mbak Dewi? Okay, it is similar with Mbak Dewi with 4,500,000, etc. So as you can see, it is the same answers that Mbak Dewi already explained and given. And for this visualizations. As you can see here in the graph, the 3 points that we calculated, that we input, is what 2013, 2014, 2015, and this is the 2016, the points that we want to find the interpolations. Okay, next is with the second example that was being explained by Mas Tolib. As you can see, there are 7 data in this example. So we press 7 data. The first data is data 1, 5, 10, 15, 20, 25, and 30. Okay. And the Y1 is 50, 70, 65, 75, 85, 80, and 60. So the data that we want to interpolate is X at Y. We want to find the number of passengers at day 18. So we press 18 here. Okay. So the result is 82.4. As Mas Tolib explained before, the result is similar, 82.8 passengers. So actually, it's the same answer as 82 passengers. And again, the visualization here, as you can see, we are given 7 data points, and we want to find the specific data points here between day 15 and day 20, which is day 18, and it turns out to be at this point, which is when we draw the line here, it is on the line, so it's correct. Now, for the third example that was been explained by Mas Muammar, is about temperature. There are 5 data. The first data is at 5 a.m., 6 a.m., 8 a.m., 9 and 10 a.m. Now for the temperature, first temperature is 16, 18, 22, 24, and 25. Now we want to find the temperature at the 7 a.m. Okay, so as you can see here, the result is 99.9 degrees Celsius, which is the same as Mas Muammar explained. And as you can see here on the graph, we are given with again 5 point here from the 5 o'clock until 10 o'clock, and we want to find the data in between of them, which is at the 7 a.m. And when we draw a line again, the data that we have calculated before is on the track with the graph, so it is again correct. Okay, it's been from us. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
So